Um, Before I talk about web applications, I'd like to make a short detour. And the year is 1996. We only have Mosaic browser, we have Netscape Gator. And there's this company based in Santa Clara, California, which is about to release a next big thing. So they said that it's going to kill desktop computers. And this is not just a regular company, it's called Sun Microsystems. It's a company that pioneered corporate computing, CPU manufacturing, and they also made a Java programming language. So what they released is called the Java Station. The year is 1996. They called it a thin client network computer. So this was a device that could sit on your desktop. You could plug in your mouse, your keyboard, your display, and it didn't have a hard drive. It was just it had an operating system called Java OS, written in Java. So the way it worked is basically it would boot up. It would take the Java OS from the flash memory. It would load up the operating system, and then immediately after that, it would open up a browser. In this browser, they had apps, which are basically web pages. So you go to a web page, and there's a Java app, an application that can be executed by Java, by JVM, and you can interact with that application. So those applications were really rich, and they looked just like native apps. So this is an example. It's like a word processor called Coral Office, and as you can see, it runs entirely in the browser. So this is Java app. So these applications could work entirely over the network. So basically storing the state. If you turn this machine off, if you turn it on again, your state will be the same because the state management work over the network. So this, I think, was revolutionary, right? The Mosaic was just 2 years ago released. There was Netscape Navigator. JavaScript wasn't even a standard, right? But unfortunately, the Java Station completely flopped. So Sun had to shut it down, and then in 2007, Sun was acquired by Oracle, and basically this company ceased to exist. And why it happened? Well, basically because there were many complaints about this device being slow. The support for Java was not that good. There was not a lot of applications, so people are not happy with that. And but I think what actually happened is when I explained that we should take a look at this concept of the innovation S-curve. So it's basically a model to explain how technology evolves over time. So first it starts slow, then there's like a rapid growth, and after that there's like a plateau where the technology is mature. So the Java Station was a revolutionary concept, but it was just way too early. There was no foundation, there was no standards, so that's why it didn't lift off, even if it was much more powerful, I think there was the chance of it being successful was super small. So why we can use these S-curves? Well, first of all, we can predict when the technology is going to be ready for adoption, and second of all, we can see what ideas can be revisited soon. And this story, I think, is quite inspiring to me because I feel like this really resembles the way the web ecosystem evolves, right? So in this talk, I'm gonna take a look at how we got to this point, what problems we were trying to solve, and what is coming after that. But first, let's take a look of how we as developers progressing, right? So we're always trying to balance out three things. So first of all, there's like the expectations from our users, the user experience. Then there's a state of the platform. So it's a state of technology. What is even possible right now? And finally, there's like a developer experience. It means how efficient, how fast we can ship this, right? And well, first of all, there's a thing that people just want more from the products. They want more from apps. Because when the new tech comes out, they have higher expectations. So this is the reason why you wouldn't use like a disk phone, right? And the second thing is, when the technology is new or it's evolving, the developer experience is at this point is low. So the tooling is still developing. So we need some time to get to that point eventually. But now I just want to get back to the good old days. We had have a human, right, a user. The user interacted with their computer, right? So this computer, probably a desktop computer, maybe in their bedroom. The way it worked is you take your application, you click, and then you see the result immediately, almost immediately, right? And we tend to think that back then the programs were not that powerful, but this is not true. For example, there was a way to create 3D graphics, recognize handwritten text. So these applications were really, really powerful back then. And I'm going to use this example of a plant collection app. So this is an app where you can take a look at the gallery of plants. You can choose a plant from the list, and you click on that, and then it gets added to your collection. So with desktop apps, basically it happens almost immediately, and all the data is stored on your hard drive, and then the next time you open your application, it's there. So, but here's the thing, if your computer dies, right, if it catches fires, all your files are gone. This is, well, you don't want it to happen. The second thing is that maybe your computer is not powerful enough, maybe you want it to do more. And maybe you want to share this knowledge with others. Maybe in our Plants app, we want to see other people's collection. So what we did is we take this computer and we kind of move it far away from the user. So then in the mid-90s, we got the browsers. We still have this user, we still have the computer. They're in the same bedroom, but now there's a bigger computer, somewhere in San Francisco, right? And we take the browser, we talk to that bigger computer, to the server, and the server sends us the HTML, and then via the browser, we can display it to our user. And then we realized that what if we can generate this HTML dynamically, right? What if we can take the HTML, execute a program in some programming language, and then serve it to the user? And this means that your computer now becomes more responsive. Now it can basically react to your state, to your session. And that makes it more relevant just for you. So it's not a desktop computer anymore. So let's take a look at how our plant app might look like if we used like an old school tech, right? So basically, you go to the website, then you wait a long time while it all loads. But I remember that this wait was totally worth it, right? So what you could see on the screen was like, wow, this is so amazing. And yeah, if you needed to add a new plant to your collection, then you had to wait all over again, wait until the page refreshes, and you know that, right? But the thing is, your browser is probably the most backwards compatible thing that you use. So even if you have this website now, if you open your browser, the chances are 99% of the things will still work. So I think this is truly amazing. Well, yeah, I mean, this is what we got. Well, we realized that if we add a little bit of JavaScript, we can also basically improve the user experience, because now we have the new technology, but this technology is it's not the same as the desktop app experience. So we realized that, and we added JavaScript, and now we have interactivity in our browsers. And yeah, we realized that there are so many things that we can do with JavaScript now. So what if we just take this generated HTML? What if we just respond with an empty HTML and a bunch of JavaScript, and then the smaller computer will take that JavaScript and render a page right on the device. So this is the concept of single page apps. And the way it would work is you go to a browser, it loads the page, and then it shows you like some kind of a spinner, while it takes time to fetch the data or to render everything using native DOM APIs. And yeah, and after that, you basically have the application and it renders instantly. And then we realized that if we want to write everything in vanilla JavaScript, that's not going to be an easy job. Even if we use like a library like Backbone, I knew some developers who used Backbone to create large applications, but trust me, it wasn't a pleasant job. So it required a lot of setup, it required a lot of analysis. So this is why we realized that now we have to iterate on the user experience, and we have to have something to speed it up, right? And luckily, now we have the platform advancement. JavaScript is now fast. There's V8. There's some nice browser API to work with history, so you can do navigation and so on and so forth. So we started to introduce Vue libraries, right? Initially, there was like, Backbone came out in 2010, and Backbone Backbone didn't have a embedded template solution, so they recommended to use underscore or handlebars, for example. Then Ember.js came out. They had a slightly different approach, and then finally in 2013, React came out, which was met with a lot of criticism. Right? Developers were really mad at React. Like, hey, if this is not going to work, but it worked. I'm not gonna talk a lot about how React works, but I want to focus on something else. I want to talk about the alternative approach that Ember.js, for example, used. This is the approach that Angular as well introduced in 2011. So let's say, for example, that we are building an app for light switch, right? So what we want is we want to have like some kind of state. We want to make a string of the state, like on and off. Then we want to render it in our HTML. And finally, when there's like after a certain timeout, we want to turn the light automatically off, right? So yeah, Ember.js proposed this idea, and this model is basically called Ember observables. So they had observable computed value and the template where this was used. And you don't have to really read this code because it's really like 13 years old, but it's just give you an understanding of how it what it looked like back then. They had like special functions to define computed properties, and then you also had to create like a special Ember object. And then after that, these values are automatically bind with the DOM. So if any of them changes, the DOM will update automatically. And I think, yeah, this idea was really ahead of its time. Basically, use properties that can be observed. You can then use dependency tracking, like a graph, to detect when they change. And when they change, you can take like particular pieces in the DOM and only update them, not the rest of the application. But if we look at how like libraries evolve, we can see that, well, Ember is still around, obviously, but it's not, of course, as popular as React. And it's a niche technology now, unfortunately, and we will later on see why it is like that. Well, then we realized that this moment when there's a flash of blank page, right, when your single page application boots up, there's like a brief moment when your app is not ready yet, and we realized that probably this is not a good user experience, right? If we compare it to the CGI era, this was instant. Now it's not. So, I mean, the user experience has gotten worse. So we have to solve that. The way we solve that is by using server-side rendering, right? So what we would do is we would, the server, the big computer would send us the server-rendered HTML, actually executing the SPA app, and not just generating it using CGI. And then the computer would first will display this HTML, then it would spend some time hydrating it, and then after that the page will become fully interactive and the user could interact with it. Yeah, well, in some sense we can say that the user is now, again, closer to the computer, right? So now we're still in the same bedroom, but now it feels that we're getting even more closer. So let's look at the timeline of SSR. Basically, the concept was first introduced in this article by Node.js. It was in 2011. They talked about this concept of isomorphic JavaScript. Well, they realized that now we can execute JavaScript on both server and client. So why don't we run the same code? And then we had some after like 2 years, basically, React came out, and I think it's quite notable that React, when it first came out, already had support for SSR. So there was like render component to stream. It was already available. And if you look at other libraries, they didn't have it. So Ember waited almost 3 years to introduce that, and Vue came out at the same time. So now we can use things like browserify to compile the code for the server, the client code to the server. So this tooling was available, and that's why the technology was ready for that. If we look at the S-curve again, we can see that React came out at the perfect time, right? When we already had the foundation, but it was just beginning to lift off. And then Ember and Angular, unfortunately, they were quite late to the party. So yeah, that's the reason why maybe they're not as popular as React now. I'm sorry if I offended anyone. Well, if we bring back our server-side generated app, we can see that the browser now can respond with an HTML immediately, right? But unfortunately, if you try to click on that, nothing will work because until it hydrates, you cannot interact with the page. So hydration is like taking the app, rendering once again, comparing it to the real DOM, and then only after that your app is ready. And it turns out that getting SSR to work was quite a heavy task. So we had like some dedicated teams working on just configuring the build and stuff like that. So we needed some way to speed it up, right? So as developers, we need some way to be more effective. Yeah, so if we look at the timeline again, we iterated on user experience a lot. We have now the right foundation with component-based view libraries. And there was some advancement in the platform, right? So ES6 was standardized. There was dynamic import fetch, everything to allow us to introduce full stack frameworks, right? So the idea of full stack frameworks was to improve that developer experience of SSR apps. So actually, we're still iterating with that, right? So the next came out in 2016 for React, Nuxt for Vue 2017, and now in 2022 we still have like SweatKits, Quick City. I think there's like Solid, like a framework for Solid. Why we need these frameworks? Well, basically, thing number one is to have file-based routing, so we can develop like larger apps. The second thing is that we don't need to worry about setting up SSR anymore. And then there was already like some recommended tooling, like running test runners, linter, and stuff like that. But in the meantime, the market was evolving, and then there were quite some developments. We realized that the expectations of our users are now even more higher. So they're not happy with like, you know, apps that are like less functional. They want like bigger apps. They want more functional apps. So it all resulted in this. Basically, we have more complex apps. We have more JavaScript, and we have more computation. And now the JavaScript is not as responsive as before. So we have two issues. Number one is the performance of re-rendering. And it means that if we click on something, how fast it can react to the changes. The core Web Vitals metric is INP, Interaction Connects Pane, that we should care about. The second issue is the performance of hydration. So how soon your page can become interactive. And this is time to interactive. Let's look again at our human-computer diagram. The server provides an SSR, like right, the server-side rendered page, and then it takes some time to basically hydrate the page. Now it's interactive. If we then perform an action, we need to, it re-renders, and only after that it's ready. And this delay might be significant for our user. It might not be instant. Yeah, so what we did was basically we split them apart, right? They're still in the same bedroom, but the experience is not as smooth as before. There's just going to be a quick crash course of how rendering works. I'm going to use React as an example, like a virtual DOM. But basically, the problem is that when you work with frameworks where there's like a virtual DOM, even if like the only way that your app renders is by the state of one of its component changes, right? So there's like an event handler, and probably it changes the state, and then the whole rendering, the whole tree of components basically is becoming, will re-render. So even if the change did not affect like a component, or only as the sidebar component, we still have to render everything. So this is an issue. If you're curious about how React really re-renders, there's a nice article that I'm gonna leave a link in the speaker notes. So okay, now let's talk about how we can deal with that. How we can deal with slow re-rendering. The first approach is compile time reactivity, right? So it was introduced by Svelte. I think Solid also uses that. It basically means that we take your code, we compile it, and then we can basically find the exact same places where the data is being changed, and kind of compile it to like bare JavaScript. So that's why it's efficient. The second thing was introduced by React. It's concurrent mode. The idea is that re-rendering it's still slow, but what we do is we split it into chunks of work, and then we take like breaks in between, so that it can yield back to the main thread. Not as good, but yeah, kind of work. And then finally, the thing that is happening right now, and I think there's another talk that was earlier today about React compiler. The idea is, well, it's not as granular as compile time reactivity, but basically they take your code, they try to optimize it by memoizing dependencies and memoizing components. And finally, there is one approach that I'm particularly excited about. It's called signals. So this is, I think, trending now. Jotai, this state management library for React, uses that quite a lot. There's Preact signals, there's Solid signals, and now last year there was a proposal to have like native support for signals. So basically, what signals allow you to do is that to take your app and describe the state as a graph of dependencies, right? So this is like a similar example. We have the light switch. There's it's a signal, it's a state. Then there's like a computed value out of it, and then there's effect that is going to run when this value changes. And this is basically the same code. This was for Preact, and that one is for rules in Svelte 5, which came out, I guess, months ago. I really recommend you to check this out. I think it's pretty dope. The only difference between them is that in Svelte they optimize it, and now you can just use like a setter, direct setter, because they use some compile time magic to do that, and Preact doesn't do that. Anyway, you might say, well, wait a second, that looks familiar. Isn't it the same model that Ember revolutionized like 13 years ago? And yes, it did, and it's exactly the same concept. They just used a different terminology. So that's the thing. Ember proposed this too early. There was not enough foundation. There was not enough people were still figuring out how to write JavaScript, right? And for example, there was not even like a proxy API that Svelte uses, nothing. So that's why it didn't lift off. So this is really unfortunate for Ember, because I think it was like some real smart people are behind it. But at least it's nice that now we're seeing the similar concepts that are being used. Now let's talk about slow hydration. Again, hydration is the process when you take the existing HTML and you make it interactive. And there are two things that were introduced. The first technique is called progressive enhancement. The idea is that, okay, let's hydrate it anyway, but before it is hydrated, let's make sure that the app is still kind of works like an old school app. Like, for example, if you have a link and you click on that link, it's just a regular HTML. But then after that, it becomes interactive. So this is approach number one. Remix uses that, Svelte Kit with some tuning, and Quick as well. And then the second technique is partial hydration, which was introduced by Astra. And now React Server components, especially their support in Next 14, right? They allow you to basically, the idea is that the content in your app is not equally dynamic. So some parts of it are more static than others. Some are more dynamic. So they propose that what if we take those parts that are more dynamic and only hydrate them. So let's take a look at our client app. Basically, we load it, and then instead of hydrating everything, we only hydrate that part, which is more interactive. The sidebar and the top bar, I mean, they're quite static. They don't change that often. So yeah, this architecture is called the islands architecture or server components. Now there's like support in Fresh framework for Dino, and then one outstanding, I think, method was actually proposed by Quick. Quick was like, okay, what if we don't hydrate at all, right? What if we don't need to like rebuild everything? What if we just run it, run our app on the server? Then we kind of save it as a like saving a game state, and then we load that state again when the code runs on the client. Unfortunately, I don't have time to talk about that deep, but if you want, we can talk about that after my talk. So now I just want to touch on another concept which I think is quite essential for performance. Basically, we have our human, we have computer, we have a bigger computer somewhere in San Francisco, but it's still quite far away, right? It's not in our bedroom. Well, what we can do is, yeah, by the way, we've been kind of moving our user towards the computer, so they're close again because hydration issues and re-render issues are solved now. So what we do instead of 700 milliseconds that takes to go from San Francisco to Tokyo, we introduce the third computer, which is a bit bigger, right? It's supposed to be bigger, but anyway, it's an edge server in Tokyo, so the response time is now less. So this is called the edge computing, and it was proposed by, I think, Cloudflare workers revolutionized it. But yeah, well, basically we have now another improvement in user experience. Now we have everything like that, and now we can iterate and like making our apps faster and the user experience better, right? But then we actually figured out, oh, wait a second, there's so many runtimes, there's so many things now, and now it's confusing for us as developers. And that's why we started to introduce like another concept, which is more about like dealing with lots of different runtimes. So this is the concept of the motto is write once, deploy anywhere, right? I just want to highlight some projects. So first of all, Remix has adapters for like quite some popular runtimes. Then there's Hona, a web server for like multi runtime. You can run anywhere. And there's like an interesting project called SST, which is like you can describe your app as a dependency of databases, and then it can be deployed to anywhere. I don't have a lot of time, but I'm gonna just speak about what is trending now. So first of all, the thing one I think is trending is the all-in-one tool chains. The thing is that now we have everything. There are so many apps and so many developer dev tools. Now we just need, it's not clear how to write JavaScript. So now we have like the rise of tools like Biome or OXC by the Wheat team. What they're saying is that, hey, we are going to release one big toolkit that is going to cover everything. Test running, linter, prettier, minifier, whatever. So the idea is not new because languages like Go or Rust have this tooling, and I think it's really interesting that it's coming to JavaScript now. The second thing is backend first. Again, I don't have a lot of time, but Ruby on Rails is trying to promote it. HTMX, kind of cool. Yeah, they're like, oh no, we don't need frontend. We can just generate the HTML like we did before. We're just gonna add a little bit of interactivity. We don't even need to ship JavaScript, right? Just one library. The final thing is leaving the cloud. There's been a lot of discussions on basically, on Twitter, like there's a drama about Vercel lock-in and stuff like that, and DHH reported about Basecamp moving away from cloud to their own infrastructure to save some money. And why it is happening? Well, I think it's not only about money. I think it's really about ownership. The thing is that companies are trying to get back the ownership of their infrastructure and their code. They wanna have control over it. And there's this thing about ownership in web apps, and this really trending thing called local first apps, local first, which was introduced by this research library, England Switch. So they talk about that we want to have the same ownership that we did when we had desktop apps, but we want to bring it back to our web apps. So I'm running a little bit of time. We have 2 minutes. And you have 2 extra minutes? No? Okay, I'll just wrap up. 1 minute, sorry. So yeah, basically we're taking the database from the bigger server and then we're moving that database here. So now it lives here. What we can do is we can synchronize it in the background with everything and then it can run entirely in the client. Some things is VAS and CRDT, file system API. These are all things that we now have that we can use to do local first apps. I have it in the speaker notes, but basically there are quite some interesting frameworks, some software for real-time collaboration, and some VASM compiled DBs like SQLite and Postgres. It's really cool. So what's going to happen next? I don't really know, but I can maybe speculate on that. And there's one thing that we cannot ignore, which is AI, right? I think it's important to talk about that. So where will AI live? Will it live like it does like now on like bigger machines? Or maybe it will live on the edge server? Like, actually, this is already happening with Cloudflare AI workers. Or maybe it will live here in our bedroom with our computer. And yeah, well, there is like some state-of-the-art projects, like you can run vector search for RAG, or you can do web GPU. There's even like window.ai, which is like a really lightweight LLM in your browser. But I think finally, just want to talk about like this concept. I really recommend reading this article. It's about like the future. The idea is that systems are becoming distributed, and our apps will be hybrid. So it's going to be everywhere. We're going to be running code in the browser, on the edge, and somewhere in the server, and we're going to synchronize back and forth. So a bit of personal story to finish. 3 years ago, I was burned out. I was feeling overwhelmed. I was not following what was happening in the web world. But then I started to like catch up, like listening to conference talks and stuff like that. And you know what? I feel excited about the web again. I feel like it's really exciting times. And I'm telling you that because I feel like a lot of people in this room have the same feelings. We feel that maybe, feelings like, am I becoming outdated? Will I be replaced by AI? But I think in this talk, I'll try to explain like how it evolves. And in reality, it's not that scary. We can see that a lot of old concepts are getting revisited, and basically it's all about like us becoming better and more efficient developers. So thank you for your talk. Using this QR code, you can get the slides and the transcript of my talk. Just want to say a shout out to my friend who did all these nice illustrations. どうもありがとうございました。